Okay, so now we can use the sample to test the null hypothesis. So we talked about the null and alternative hypothesis a little bit prior regarding if like kind of errors, right, with type 1 and type 2 errors. Like, what if we say there's enough evidence to support the claim when there actually wasn't, and we should have just left things as status quo? So here, when we observe results that are unlikely under the assumption that the null hypothesis is true, we say the result is statistically significant, meaning that if I make a claim and there's enough evidence to support the claim, kind of like guilty and not guilty. If there is enough evidence, we don't say if the person is not guilty, it doesn't mean they're innocent. It means that there was just not enough evidence to support the fact that that person on trial was not guilty. Um, was guilty. So here, if you make a claim, and if there's enough evidence to support the claim to change the status quo, then we call that statistically significant. So what does that really look like, visually? So when we find that we make a claim, for example, someone is on trial and there is enough evidence to support that person to determine that they're guilty, then that's statistically significant, right? So what does that mean in terms of hypothesis testing? Well, the null hypothesis is status quo. So if something is statistically significant, then we reject the null hypothesis. And this is the most important part. We do not look at things, we do not look at these hypothesis tests in terms of the claim. We look at it as keeping status quo. We're like, no, 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 this is how it is right now. We're keeping it. And if there's enough evidence to support the change, then we reject status quo and we can accept the change. And what that change means is the claim, right? The alternative hypothesis. So we have everything's in terms of the null hypothesis. We either reject the null hypothesis or we do not reject the null hypothesis. We reject the null hypothesis when we find evidence that is statistically significant. Okay, so it's a lot to take in. So how do we do this? You're like, okay, great, I get it, but like what am I going to use to reject and not reject the null hypothesis? Well, that's called the p-value. And so the definition here says the p-value is the probability that if the null hypothesis is true, so if the null hypothesis is true, the results from another randomly selected sample will be as extreme or more extreme as the results obtained from the given sample. So going into more technical terms, if the probability of making a type 1 error is more than the p-value, then this is statistically significant and we reject the null hypothesis. So technically, we're going to get numbers and math, right? And what the second statement is saying is if the alpha, this probability of making a type 1 error is more than the p-value, we call this statistically significant and we reject the null. If you get that the alpha is smaller than the p-value, you do not reject the null. So these are the two cases we're going to have. The alpha, again, is given to us in the problem. If it's not, then we usually default to like a 5%, right? That maximum probability of unusual events. And the p-value, plug and chug in the calculator. So all we're doing is trying to get to the place where we talk about, do we keep status quo or do we not keep status quo? Let me draw a picture because we're going to be drawing pictures of this. So let me go ahead and get a big, thick drawing marker. Okay. So here, let's say I have, let me do it in, okay. So here's the the alpha, right? And here, and this is going to be like T sub alpha or Z sub alpha, right? Depending on what distribution we have. Okay, and then this is like the tail, right? So this is the probability, right? Don't forget the probability of making a type 1 error. Okay, so let's do the first case, and I'll do that in green. So if the probability of making a type 1 error is greater than the p-value, so the probability or the area here will be less than alpha, right? This is, get the green, let's say it's here. So here's the p-value, that's the area, the probability, and if this area is smaller than making a type 1 error, then we can reject the null. So what does this mean, right? So again, if the area here in the tail, okay, so that is a probability of making a type 1 error. If that probability of making a type 1 error, meaning that we do not reject the null when we should have, right, is larger than the p-value, right, the probability that we will randomly select another sample and get the same results is smaller, then we have to reject the null. This is statistically significant. So let me try to explain it in another way as well. So the p-value says that if you take another sample and test it the same, that the p-value is that probability that whether or not you're going to keep status quo depending on your alpha. If you find that the probability is smaller than making a type 1 error, then you are not keeping status quo and that results are statistically significant. But if you take a random sample again, and let's say the probability of getting the same result is larger than making that type 1 error, it's saying that there is no change and you're keeping status quo, which is the next part. So here, this situation says that if I took another random sample, right, another random sample, the results will be extreme or more extreme than making a type 1 error, and therefore being statistically significant. So what you're looking for is it status quo or is it not status quo, right? So if this case here, it will be statistically significant. So then the next one, let's see, here's pink. If the alpha is smaller than the p-value, so that means that here, you know, here we go, get red. So this means that the p-value is greater than the area, right, of alpha. This means you do not reject the null. Because why? Because you took another sample. The probability of taking another sample and having the same results is actually larger than making a type 1 error. Therefore, there is no change. The probability of that occurring where something's going to be different is larger than making a type 1 error. It says you do not reject the null, then there's not enough evidence to show that there's change. Keep the status quo. Keep the null hypothesis. So what does this mean for you? Again, I just want you to kind of deeply think about the concept of a p-value. And so mathematically what we're going to be doing is just kind of running a process over and over again and basically for the rest of the semester we're going to be doing hypothesis testing. So what you're going to do is these math stuff in the calculator, but the idea behind the p-value has strength to it, and that's how we make our even in higher research methods courses, you use the p-value. So let's just go ahead now and take an example. So a normal distribution, so it has a standard deviation of 1. We want to verify a claim that the mean is greater than 12. A sample of 36 is taken with a sample mean of 12.5. Draw a graph that shows the p-value. So here, the first thing we want to note in this case, right, is we have, it is given that the population is normal. Okay, 2, right, that a sample of 36 is no more than 5% of the population values. And so we assume these 36 because who knows how many values are out there. And then and so these two are both the preliminary, right? Are both satisfied. And when they ran the statistics, they set up the hypothesis as the null status quo. If the mean is greater than 12, that's the claim, right? I put a little C where the claim is always. That means the status quo is that there was no change. Let me write. Right, so remember the null is status quo, meaning no change from 12, right? When they ran the stats, they got a probability of 0.0013. So the first thing we want to do is go ahead and label the graph. So here's 12. And if we're testing about a mean, recall that the sampling distribution with respect to, the mean with respect to the sampling distribution is the 12, and the standard deviation is the population standard deviation of 1 over the square root of the sample size. So this is just 1/6. So if the mean here is 12, then this is going to be 12 and 1/6, so 12.67. So let's do it in our calculator. 1 standard deviation away, and then 167. And then let's go ahead and add another 1/6. And we get 12.33. And then you can add another, so you can see that I'm just adding the standard deviation, 12.5. And so if we did 12 minus 1/6, right, that'll give us 11 and 8.3, and one more, 0.67. And then one more, 11.5. So you'll label there, and then a p-value of 0.0013, that's really small, right? Because we know this tail here is like 0.5%, right? So here, let me go ahead and try to mark it in red. So 0.0013. Okay, and so depending on alpha, we use p to, again, reject or not reject then I'll